we okay with the angle conversion?
Yeah.
All right. So now, once we're here, we're just gonna figure out what the cosine of 60 is.
Right.
So we could, I kind of was a little lazy. We already have the pictures. Better would be to just practice, okay? 60 degrees. Put me in the first quadrant. Oh, here's 60. Drop my perpendicular.
Right.
30. Opposite 30 goes a 1. Opposite of 60 goes a root 3. Hypotenuse is 2. Cosine is adjacent over hypotenuse.
Got it.
Sine, opposite over hypotenuse. Be careful. Sometimes this gets flipped around, and you say, oh, 3 is bigger, because sometimes you're like, oh, the biggest value goes on the hypotenuse, so you see the 3, and you say, oh, the square root of 3 is on the hypotenuse, but really, if you punched up the square root of 3 in your calculator, it's like 1.7. So be careful, 2 is the largest value. Sometimes people forget the square root here, and they kind of, I think, are mixing up the two of them. Okay, so all of these pictures are my method for not having to memorize the unit circle. So if you memorized the unit circle in the past and you have it memorized, you can absolutely just do it that way. I don't memorize the unit circle, I draw pictures. It takes you all about 2 seconds to do it once you are comfortable with it, and there is no memorization. In fact, once we get all the angles around the whole entire circle, there's pluses and minuses all over the place and it's just kind of weird. Well, it's not weird, it's just easy to make a mistake if you're memorizing something. All right, 657. So now we're done with those 4 problems or 5 problems that you have for homework. We've got some word problems that we have asked. Okay, number 57, the distance of a descent. So this is a word problem. An airplane traveling at, oh, you're gonna love this one, 240 miles per hour is descending at an angle of depression of 6 degrees. How many miles would the plane descend in 4 minutes? Okay, so you draw your fabulous plane, which, with respect to the horizontal, is how we are going to measure the angle of descent. Okay, so the angle of descent, it says, is angle of depression, angle of depression is 6 degrees. So with respect to this horizontal, it's decreasing an angle of 6 degrees. It's going 240 miles an hour. And it wants to know how many miles will the plane descend in 4 minutes. Is that how far it's traveled? How far has it descended is the vertical distance. Is that what your problem was? Did you find the hypotenuse?
Well, it wasn't me that asked that,
Oh.
but I just realized that I got it wrong too.
Okay, so we want to know how far it's going down, and we're doing this for 4 minutes. And of course, we're going to draw the vertical distance, so it's going to be perpendicular. All right, so we have unit problems here as well. Hopefully, we all know rate times time equals distance, right? So that's one issue, is we are looking for how far, and we want a distance. However, they gave me how fast it's going and how long it's going to go at that rate. So we need rate times time equals distance, and then bonus, this is miles per hour, and we got 4 minutes. So we have to convert. So it's not as super easy as you might have thought, in which case that might be, if you're like, I thought I did this right, why did I get it wrong? Could be your units. Okay, so we need distance is rate times time. Should we continue, or does this answer whoever asked the question?
Keep going.
Keep going? Okay. We're probably going to want this in miles. So So we want this distance. The rate is 240, and the time, okay, 4 minutes. How can I convert 4 minutes to hours?
Divided by 60 minutes.
Divide by 60, or you're like, okay, I'm gonna do my unit conversion. So be careful, make sure 60 goes in the right spot. Okay, so 4 goes into 60 actually 15 times, so this is 1/15 of an hour. So we're gonna write 240 times 1/15. Okay, please get used to not using your calculators just because you're not gonna have your calculator on your test. And I know this is gonna be a nice number, I think. But just be careful. 24 is divisible by 3, and 3 is divisible into 15, or 15 is divisible by 3. So you could do the 5 first, but I'd rather not think that hard. It seems easier to me. So if I divide by 3, 24 divided by 3 is 8, so this is going to be 80. Okay, cancel. Cancel now on your homework so that you're prepared for that on your test. All right, now, whether you say 5 into 80 goes once, carry the 3 and 16, or however you want to do it, or you just know that 5 times 16 is 80. 16, let's see, we just multiplied rate times time, so this is 16 miles. All right. You're so excited. All right, we got our length. We want this length. The angle we have is outside the triangle. Kind of a bummer. We need an angle in the triangle. So, what are we going to do? We could totally, if I'm going to measure a vertical distance, it's going to be with respect to horizontal, so this has to add up to 90. If you're like the pro geometry student, you've got 2 parallel lines cut by a transversal, alternate interior angles are equal, but you probably don't remember that. Most people go to say, this has got to add up to 90, so I guess this is 84. And now you're going to think to yourself, which of the main 3 trig functions, sine, cosine, tangent, can we use for 84? This is the adjacent, and that's the hypotenuse. Okay, opposite would be over here. So if you wanted to use sine, you could actually use that one. It's 6 degrees. Okay, but we can then say, so now we're going to plug in all the pieces. We're using adjacent, hypotenuse is cosine. The cosine of the angle is adjacent over hypotenuse. How was that? That was easy. Well, I shouldn't say now it's easy. I do want to solve for x. I want to find that distance. I want to get x by itself, so we just multiply both sides by 16, so that x distance is 16 times the cosine of 84 degrees. Test, you're going to leave your answer like that on the test. We have no calculator. We have no, now if this was 60 degrees here, you absolutely are going to go further, because the cosine of 60 you can figure out. 84, bum kiss, can't do it. Okay. You're going to be done. The directions will say express your answer in terms of a trig function. 16 times the cosine of 84. You're checking your answer in the back of the book because they don't have this in the back of the book. Absolutely, grab your calculator.
Could it also be 16 sine of 6?
Yes, it could be 16 sine of 6 as well. Absolutely. So now I've got 16 times the cosine of 84, and we have 1.67. Okay. Remember, the very end of class on Wednesday, we talked about the rounding that is introduced in this section and will be carried out throughout the course. When I have my angle to the nearest degree, how many significant figures do I give my answer as? Side lengths get given to 2 significant figures. So we're going to look right here between the 1.6, but that 7 is going to do what? Round it up, so we're going to give our answer as 1.7, and we are miles. Okay? We also could have done 16 sine of 6, which will give you the same thing. All right, so that's 57.
So why can't it be both 16 cosine 84 and 16 cosine 6?
If you did the cosine of 6, so this right here is 6, adjacent, you'd find that length.
Yeah.
You'd find
Oh, right. I get that.
how far in a horizontal
Right,
distance
right,
the plane go when it descends.
Right.
I mean, you can absolutely, but it's not answering the question. All right. Is that one, that area one, number 67?
Wait,
Yeah.
What?
Oh, no,
No,
nobody asked
63.
for that one. Oh, yeah, wait a minute, 63, it is that one.
Yeah.
All right. I love this problem.
I don't.
You know what's so awesome about this problem? Okay, this is what you got to get used to. In math, especially if you're going on and you're taking lots of math, or you're working on a word problem, you may not know what to do, but you're just going to do something. Okay? You have no clue that it's going to help you get to the end result, but you're just going to do something. So, 63. All right, area of an isosceles triangle. Consider the following isosceles triangle. The length of each of the two equal sides of the triangle is A. So they actually kind of helped you define an isosceles triangle a little bit. Here, I can make my colors match actually. Isosceles triangle is one where the two sides are equal. They've got it drawn just like that. Oh, except that's black. I should probably not worry about this so much. Base angles of an isosceles triangle actually are equal. Okay. And the base angles has a measure of theta. Verify that the area of the triangle is. Sine theta. Cosine theta. And conveniently, they draw your perpendicular in. And it's going to be a little bit different than what we started with because they have this labeled as B, which is not what we did. I kind of like that thing, but we'll do it this way. All right. We're going to verify that the area is that. Okay. Area. We got to start somewhere, and there's no way that we're going to logically say, oh, the area is this because blah. You're going to do some math. So let's start with area. What do we have here? Triangle. What's the area of a triangle?
1/2 base times height.
That's where we're going to start. Area is equal to 1/2 base times the height. We're going to put our height right there. All right? Height is easier. So we're going to do the height first. Okay? We can also kind of look to see what do I have and what do I want to get. I want to get trig functions and I want to get side A. We actually don't want side B, unfortunately, because that happens to be your base. Bummer. But we need side A and we need trig functions. So, height. If we want to just focus on one right triangle, because SOHCAHTOA deals with a right triangle. Sorry about all the noise. I want to use an angle, theta. I want A and my height. So, if I've got my angle theta, Here's the height we're trying to substitute for, and I've got A. Which trig function goes along with those side positions? Sine, right? Sine of theta is h over a. And you've probably done this a few times. We can multiply both sides by a. And if you don't mind me flip-flopping sides, h is a sine theta. Which means, I probably should write this. Let me just write this. The height is a sine theta. So, somehow the 1/2 is missing. We got an a and we have a trig function, but the thing that we have to get rid of is b. Okay? b. Ah, I don't know how many of you did it that way, so we're not going to do that way. All right. B is this whole entire side length. They labeled it like that. That is the base of the triangle. But if I'm going to try to write a relationship, do I actually want to use that letter B? Specifically, is just B. I want this part. Okay, based on the picture they've drawn, and if you remember geometry theorems, how long is this green part?
1.
It's half of it. So b over 2. Okay. So now we want to replace b, so that means we're going to focus on, we got a lot of stuff going on in that picture. We're going to focus on theta, we're going to focus on b over 2, and we're going to focus on a. And I need a trig function. We have to introduce cosine, and conveniently cosine is right there. Okay, so we're going to write the cosine of theta is adjacent over hypotenuse, b over 2 over a. We want to solve for b. If you want, we could, instead of fussing with the fraction, we could just multiply both sides by a. That's kind of nice. So we get a cosine theta is b over 2, because the a in the numerator is going to cancel the a in the denominator. If you recognize that 1/2 b is the same thing as b over 2, then you can just do a straight substitution for the whole unit. I'm not sure how many people would notice that, so we could just keep going and solve for b. So we can multiply both sides by 2. So b, it's okay that I flip-flop sides, b is 2a cosine theta. And this is what we're going to substitute for b. How is this? Could you repeat it on your own? You should try. All right, so we got 1/2. B is 2a cosine theta and a sine theta. All right. Now what? Be careful about looking at parentheses with a big white thing inside and say, oh, foil, because we have no FOIL process going on right here. If you were thinking FOIL, you need pluses and minuses going on. That's when you FOIL. I've got multiplication going on all over the place. 1/2 times 2 times a times cosine theta times a times sine theta. Do I really need those parentheses? No. So this is all multiplication. So we can just multiply. So I've got 1/2 times 2 times a. I might as well write that other a over here, so that's where I'm going to get my a squared. And if I want to kind of get myself set up, let's flip-flop the order. Times the sine of theta, cosine of theta, and we're home free because this is 1, and we get a squared sine theta. Isn't that awesome? You're like, no, not really. All right. Next problem. You're going to test your algebra skills. We're not going to finish it. I know I have a problem worked out on Canvas. I will post it in the announcement section. And I don't know if it's this problem or a problem just like it. We'll get started. 67. We have the Washington Monument. We want to figure out how high the Washington Monument is. And basically, a surveyor measured at one spot and got 42 degrees up to the top of the monument. 100 feet further, it measured up to the top of the monument and measured that the angle was 37.8. And we want to know the height of the monument, and it is not the Leaning Tower of Pisa, so it's perpendicular to the ground. All right. What makes this awful is I only know this length right here between the two triangles. Okay. We don't know anything about that. We don't know the hypotenuse. We can't figure it out. Okay. So we have two triangles. If you separate them, it might make it easier. 37.8 for the far one, h, and then this being 42, and this is h. All right. Let's call this a variable. What do you want to call it? I don't care.
X.
Oh, you know, yes. Okay, so that's this one. So what's this length here?
X plus 100.
X plus 100. Okay. So what's our thought process? No, you guys don't be shy. Go
This-
ahead.
You have to use the tangent and find the difference between the ratios.
Okay, so what we want to do is we want to look at the sides and the angle, examine the angle, the position of the sides that we have information about, and create one of our trig relationships. So tangent is totally great. Could you do something with the hypotenuse? You could, but the only problem is you'd be doing more work because I know squat about the hypotenuse. And both of these hypotenuse lengths are different. The only thing we know is this distance between the two places where they surveyed and measured the angle to the top of the building. So really utilizing that horizontal distance is going to be important. Okay, so this one, we're going to say the tangent of the angle is opposite over adjacent. So we're going to say the tangent of 37.8 is h over x plus 100. I cannot do anything with that really. Well, besides manipulate it. Okay? It's an equation in two variables. I know it really doesn't look like this, but it's basically the same thing. 2x plus 3y, oh, it's x plus 3y, equals 1. I got one equation, two variables, can't do anything with it. Unless I have a second equation with two variables, conveniently this. We can say the tangent of 42 is equal to h over x. Because when in algebra you have that, now you can solve your system of equations, elimination, substitution. Substitution is going to be a little bit nicer here. Okay, so we got two equations. It would be really sweet if we left h in the equation, since that's what we want to solve for. Would you agree? So we're gonna multiply by x. So we get x times the tangent of 42 is equal to h. And the reason why this isn't helpful is because when we substitute it, now our variable's x. Bummer. Okay, so let's just solve this for x. Let's divide by the tangent of 42. So we keep the variable we want at the end in there. So x is h over the tangent of 42 degrees, which we're now going to substitute right there and enjoy the joy. All right, we'll tear it flat. We gotta solve for h. And you're like, I have no clue. It's okay, you don't have no clue, it's fine. But we're just gonna do something. What could we do?
Right.
Yeah, we could pray, if that works.
I was just about to say that.
I don't think God is going to divinely say, do this. Okay. How much do you love the fraction? You love the embedded fraction, right? Okay, well, over here we had a much easier problem, and you're like, oh, let's get rid of the fraction. Multiply both sides by that denominator. Okay. We could make the problem look maybe a little bit nicer by multiplying both sides by this denominator. Is that the best way? I don't really know. Okay? Be careful about, has anybody said, oh, maybe we should split it up into two fractions? Okay, we're going to be careful. Let's remember, when is it appropriate to split things into two fractions and when is it not? Okay? Because it could be, if we had that, x plus 3 over 2, that can be split up into x over 2 plus 3 over 2. So when your sum is in the numerator, absolutely. Or your difference is in the numerator, we can split it into two fractions. When it's in the denominator, you're busted. Can't do it. So we could flip and multiply by the reciprocal, but in order to get the reciprocal of this, we have to actually combine it into one fraction. So we do actually have two options. We multiply both sides by the mess, or we combine this together to one fraction so that we can multiply by the reciprocal. Oh, we're out of time. Sorry. I was going to let you guys choose, but...
Keep going.
Oh, do you want me to keep going?
Yes.
Yes,
I'll keep
please
going.
do.
What do you want to do? I don't care.
Oh, I don't know.
Maybe one fraction.
Make it one fraction?
Yeah.
Simplify this side, make it look nice? Common denominator. Okay, so we're focusing on the bottom. What's the common denominator? Tangent of 42. Okay, so let's not freak out about the trig function. If we have 1/2 plus 1/3, the common denominator is 6. And how do we make the common denominator? We multiply top and bottom by what we need. This needs a tangent of 42, so we have to multiply top and bottom by the tangent of 42. Oops. Hopefully there's no Friday evening single class that's going to walk in here. All right, I'm going to just write it all in one color so it's going to look a little bit nicer, maybe. Once you have a common denominator, what do you do when you add them together?
Keep the denominator, add the numerator.
Add the numerators and keep the denominator the same, right? Okay, so now I've got h divided by this. Let's just write it. Okay. So when you have two fractions being divided, what do?
Multiply.
Multiply by the reciprocal.
Multiply by the reciprocal of the second one. So left-hand side is the tangent of 37.8 is equal to. We're going to multiply by the reciprocal. So we're going to get h over 1 times the tangent of 42 over h plus 100, the tangent of 42. And if I make this a coefficient, it might not look so weird. All right, I still have h in the numerator, h in the bottom, kind of a problem. Can I cancel the h's? No, there's a plus sign in between over here. Besides, if we cancel the h's, we have no variable anymore. It's kind of a bummer. All right. And in terms of trying to flip and multiply by the reciprocal, it's not going to be helpful. Now what we need to do is just multiply both sides by that denominator. So we're going to multiply by h plus 100 tangent of 42. We're going to multiply by h plus 100 tangent of 42. We get h plus 100 tangent of 42 times the tangent of 37.8 equals they're like, score! Let's just divide by the tangent of 42 and be done. What's the problem with that?
End up with the same mass on the other side.
Huh?
You end up with the same mass on the other side.
I have a mess on the other side. I got h on the other side. That's got to get over. I got to get my h's together. All right. I want this h over there. The h is involved in a sum, which is being multiplied by something. What are we going to do?
Foil.
We're going to distribute. Okay, we're going to distribute the tangent of 37.8. This is just a number, your calculator knows it. If this was 2, you would have no problem distributing a 2. We're going to distribute that to each value involved in the sum. So we've got this plus a wonderful mess. Okay, so we're going to multiply h by that number and this by that number. So we're going to have h, the tangent of 37.8, plus 100, the tangent of 42, times the tangent of 37.8. We're almost done. So if you're like, how much longer is this going to be? Well, we have a few more steps. This is like an ugly log problem. Although it's worse, really.
This be like a test problem.
If I say no, you're not going to worry about it. All right.
Percentage.
What?
Percentage wise, how likely?
That's got an H on it, in it. Yeah, I need to move it over. So how are we gonna move it over?
Divide.
Subtract it. So now what we're gonna have is this wonderfulness. Okay, you've done this in algebra, not with trig functions. I want to get h so that I can solve for h. There's one word, starts with an F, and it might not be the first one you think of. That's the key to finishing this.
We pull out the F.
Yeah, we're going to factor.
Factor.
Factor out the h. Okay, so we're going to factor out the h. And then it turns it into a multiplication process, and I can divide by the mess. Okay, so if I pull h out, of this, we're left with the tangent of 42. I'm losing my degree symbols. My next value that we're factoring the h out of is this here. They're separated by the subtraction sign, so now we just have minus the tangent of 37.8. You cannot simplify these. Okay, you can't just decide to like subtract 42 and 37.8 and put tangent in front of it. It doesn't work that way. Those operations are not commutative in terms of doing one way and one the other way, and you get the same exact answer. So you just leave it tangent of 42 minus the tangent of 37.8. But we have h times the mess. I want to solve for h, so we just divide by the mess. So we're going to get h equals, this is in the numerator, is getting divided by 100 tangent of 42, tangent of 37.8, divided by that subtraction mess, tangent of 42 minus the tangent of 37.8. You punch that up, you get your answer in the back of the book. Okay? Can I cancel my tangent of 42s and my tangent of 37.8? Bummer, no, why not?
Subtraction.
Subtraction sign. It actually works algebra-wise, a little easier if you use cotangent. So, when you do this on your homework,